My loyal students, the first thing you have to know is the limit. When you have a graph, for every x value, there's a y value. That's normal. However, there's something else called a limit. You write it like this, and it means the value that y approaches as it gets closer and closer to the x value, like so. This is not much different to a normal y value as long as the graph is continuous. Continuous means it doesn't have any holes or gaps. It just follows a nice connected path. When a graph is continuous, every limit is the same as the function value. Remember holes, vertical asymptotes, and jumps. When you get these, finding the limit becomes much harder, so we leave that for later. When a function is continuous, you can find the limit by plugging in the numbers like this. For piecewise functions, you need to think a little harder. If the limit is definitely inside the domain of one piece, that's easy. Direct substitution. If the limit is where two pieces of the function join together, you have to plug in the numbers to both sides. Now, there's some fancy notation for this. When you want the limit from the left side, you put a little negative sign on the top right of the x value of the limit. When you're finding the limit from the right side, you put a little positive sign at the top right of the x value of the limit. If the two limits match, then the overall limit will be the same. There's a nasty little thing called the greatest integer function or the floor function that you need to know. It's written like this, and it means every y value has been rounded down to the nearest whole number. Finding the limits of this is easy. If you've been given a fraction or a decimal, you just round down. If you have been given a whole number, the positive limit and the negative limit won't match, so you just write the in here does not exist. We've been working with the graphs and equations so far, but let's get rid of the graphs. You cannot stop and draw a graph every time you are given a limit. How about this one? Direct substitution gives you a denominator of 0, which is illegal. Even evil scientists obey the laws of math. So this is just algebra. Because it's a limit, you can cancel it out and simplify the equation without breaking it. Don't do this for finding a function value. So we cancel things out, we simplify it, and then we plug in the numbers again. If it works, great. If not, here's another question. How would you do this one? If you want the limit of infinity, take the variable with the biggest exponent and ignore everything else. If it's a fraction like this, you take the biggest exponent from the numerator divided by the biggest exponent of the denominator. If the exponents cancel out, you have a number. If you end up with a variable, the limit will be infinity or dv. Sometimes the limit might be negative infinity. If you end up with a constant over a variable, the limit at infinity will be 0. So that's all you need to know about limits.